3, 2, 1. Ignition sequence has started.
Liftoff. We have liftoff.
Fido, go. Kite, go. Control, go. Telcom, go. GNC, go. Ecom, go. The Eagle has landed. We copy you down, Eagle. That's one small step for man, one giant leap for mankind. In the beginning, God created the heaven and the earth. And God said, let there be light. And there was light. Okay, Houston, we've had a problem here.
Say again, please.
Oh, Houston, we've had a problem. And it's been a long way, but we're here. Okay, are you guys ready? Here we go. It might sound corny, but the view is really out of this world.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space. None will be so difficult or expensive to accomplish.
Of course, when I was selected for the program, I had very high aspirations of flying a lunar landing, but Apollo at that time, when Germany was going on, although it was in existence and in work, for those of us who were very deeply involved in Germany, it was still quite a step away. I used to give a talk now and then to different groups throughout the country and talked about someday we're going to walk on the surface of the moon. Not just go there, but walk on the surface of the moon. And I believed it, even though I found it hard to believe myself. I did believe it because I believed in what I was doing. But I turned around one day and I found out, gee, I was one of those guys who was walking in space. And with a little luck and God willing, I'll be one of those guys who's going to walk on the surface of the moon. And even having done some of this, it's still almost unrealistic to me. In spite of the fact that I've had a chance to fly a couple times, I've been close to the moon. I haven't made that moon landing, and believe me, it's no easier today than they were in the past, and certainly they're not for a crew who's never made that lunar landing before.
I think just like everybody else has flown, I and all the people who fly with me and after me will bring very special experience to the program. Experience gathered generally prior to becoming an astronaut and then added to while they have been an astronaut. My experience just happens to be in the field of geology, and in particular in the observation of materials of the Earth as they exist in the field. That's what basically a field geologist does. In the case of exploring the far frontiers of space, a geologist has an advantage because that's his livelihood and that's what he's been doing most of his life. I don't feel that unusual. A lot of people think of it as being unusual, but it's really just another specialty. Hopefully, we open up with this the possibilities of applying other specialists to other problems.
Apollo 17 is what we call a J mission series, or it's a follow-on to Apollo 15 and 16, where we really sort of change the capability of the spacecraft. We have more payload on this flight. As a result, we have quite an extensive and heavier scientific package in our spacecraft, which of course means it takes longer time to deploy it, to set it up, to get it working. With that in mind, and to spend additional time on exploring the geological finds we hope will be in Taurus Littrow, our landing site, we hope to spend a little bit longer time on the lunar surface. We added a lunar rover to the lunar module so that we could go further distances from the lunar module after we landed, get in areas in terms of geological exploration and exploration of the moon that we couldn't get to before.
We've been training for about 12 months, maybe slightly longer than that. It's hard to remember once you get involved in this thing how long you've been working on it. But of course, the training for any spaceflight mission begins several years before that. And for me, I guess the concentrated training for spaceflight began with Apollo 15 in the December of 1969.
This is Apollo Saturn Launch Control. We're T-minus 1 hour, 22 minutes and counting. Out at the pad, the space vehicle is surrounded by searchlights producing some 225 foot candles of light. At liftoff, approximately 7,500 foot candles will be produced from the flame of the Saturn V engines. This is almost equivalent to daylight. Our countdown continuing to go smoothly now as we approach the 1 hour mark. This is Kennedy Launch Control.
Some people think that because Apollo 17 is the final Apollo lunar landing, that it should be a spectacular of some kind, so someone decided that it would be a night launch. Well, it is a night launch, but it was not planned that way. It really came out by accident. The fact that you pick a landing site, and our landing site is in a relatively remote area of the moon in the northeast corner, the launch time of day is really dictated to us. Nevertheless, that night launch is going to be very, very exciting, as much so for the people who are watching it as the three of us who have the opportunity to fly it.
This launch will be aiming Apollo 17 for the Taurus Littrow area of the moon, named after the Taurus Mountains in southern Turkey and the Austrian astronomer Littrow. The site is expected to yield some of the oldest and some of the youngest lunar samples returned during the Apollo flights to the moon.
Have a chance to complete this first phase of lunar exploration. In last chapters of a lunar history book that Apollo has the capability of writing. We won't know it for 50, 100 years, but some of the things that we are finding that were completely unexpected, that we didn't plan to find, will almost certainly be the most important things in the eyes of the history of science, and very probably in the eyes of the history of man.
This is Apollo Saturn Launch Control. First stage, second stage, third stage, now all going to internal power. The flight of Apollo 17 will be able to be seen some 500 miles away as it goes into Earth orbit.
For the eyes of the world, now look into space, to the moon, and to the planets beyond. And this generation does not intend the founder and the backwash of the coming age of space. We mean to be a part of it. We mean to lead it.
Entering the final phases of the countdown, various elements of the team reporting in with their go, no-goes for launch. First stage reporting they are go. Range safety, they are go. Launch director Walter Caprian has given a go for launch. Apollo 17, the launch team wishes you good luck and Godspeed.
The music go. Staying on.
25 seconds and counting. We are still go.
There we go.
20 seconds. Guidance alert. The guidance system now going internal. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence start. 5, 4, 3, 2, 1, 0. Liftoff. We have liftoff.
The pad. It is now cleared the tower.
There goes the tower. Ah, there she goes.
Roger the tower. You're going right down the pipe, 17.
We're in a roll, Bob.
Roger, Gino. Looking great. Thrust good on all 5 engines.
Okay, 17 is go.
Roger, 17. You're go.
First stage looks good. Altitude 1.1 miles.
Mark, mode 1 Bravo.
Roger, 1 Bravo.
Roger, Gene. You're looking great. Right down the line. 17 Houston, your times are nominal. Nominal times.
6 plus 36 and 9 plus 20. Roger. Let me tell you, this night launch is something to behold.
Crew will experience maximum G-forces of about 4 Gs at shutdown.
Stand by for mode 1 Charlie, 17.
Coming up on first stage shutdown.
Houston, you are go for orbit. Go for orbit.
Those are kind words, Robert. We're go for orbit here.
Good show, babe. A little late, but a good show.
Outstanding ride. Sure felt like it.
We've confirmed Apollo 17 is in a near nominal orbit. The translunar injection burn is targeted to last 5 minutes 51 seconds, accelerating Apollo 17 to the required speed to get it into an orbit that'll intercept the moon.
You're looking great on a final status check here, and you're go for TLI. Houston, you're looking good, and the thrust is go.
Booster reports the thrust looks good on the S4B. The velocity increasing, up now to 26,000 feet per second, beginning to climb ever more rapidly. This burn was initiated at an altitude of about 97 nautical miles above Earth. When finished, the spacecraft will be at about 150 miles above Earth and on its way to the moon, some 213,000 nautical miles away.
Houston, you have a go for T&D.
Okay, a go for T&D. Okay, what can you do? Okay, we are maneuvering Houston. Ooh, what a beauty. Look at that. Yeah, Madagascar and Africa. What a beauty. And we got a few very bright particles or fragments or something that go drifting by as we maneuver. Looks like the 4th of July out Ron's window. No, but we've got the booster and is she pretty? Challenger's just sitting in her nest.
Roger.
I can't tell you too much, Bob, from the center seat other than Captain America is very intent on getting Challenger at the moment. Yeah, I'm coming in a little slow, but we got plenty of time.
Ron Evans now at the controls of America, moving in for the docking with the Lunar Module Challenger.
Let's suck it together. Ready. She's lined up, not bad. Okay. Prime 1. Mark it, stand by. There she comes. Okay, we got it. Oh, man, did we? Capture Houston.
Roger. This is Apollo Control. America and Challenger are on their own at an altitude of 13,000 nautical miles from Earth.
"17" to us, to the crew, is probably best summed up in the meaning of our patch as we designed it and as the ideas that we put into it. We felt certainly that Apollo 17, in spite of the fact that it's the last flight in the Apollo program, is really not the end, but rather the beginning. It's sort of a culmination of what we consider man's greatest achievements, certainly in our lifetime. And looking in the future, these achievements and the potentials of them have literally no bounds. We have the God of Apollo on our patch. He represents not just the Apollo program, but mankind himself, represents knowledge, represents wisdom. And Apollo is looking out into the future. He's not looking behind. And he's not simply looking at the moon, someplace that mankind has been, but he's looking on beyond the moon and into the future. We have, along with him, up in the corner of our patch, a golden moon, sort of representing a golden era of spaceflight that we are bringing to a close now. The achievements that have happened in this past decade were not by accident. America brought us where we are today, and the United States of America is going to lead us into the achievements and the accomplishments of the future.
This is Apollo Control. Cernan and Schmidt have gone aboard the Lunar Module Challenger, going through the housekeeping transfer of items from the command module into the lunar module, and we'll proceed with the checklist of activating the spacecraft communication system. Evans had the detail of removing the probe and drogue earlier, but he's by his lonesome back in the command module.
Gordy, doesn't look like I have a chance to go to church today, but under the circumstances, I guess it'll be okay. Next time he's a good father, you might have to put a good word in for us.
Okay, I'll do that.
Hello, Houston. I've got the moon. Boy, is it big. We're coming in right down on top of it.
Roger, that's about right. Don't worry, you'll miss it.
I just want to hear you say it, because I'm going to hold you to it.
Hello, America. How do you read Houston? Over.
Hello, Houston. Houston, this is America. You can breathe easier. America has arrived on station for the challenge ahead.
Challenger Houston, you have a go for undocking and SEP.
Roger, understand, and go for undocking and SEP. 3, 2, 1. We got it. There we go. Okay, looks good on board.
Okay, looks good on the ground.
Now, the landing site of Apollo 17 Taurus Littrow is, and I'm speaking from the guy who's actually going to fly the spacecraft, to land it, very, very challenging. It's sort of a box canyon surrounded by mountains on 3 sides, and a landslide that comes off one of the mountains that has some rubble that is strewn across some of the craters just in front of where we're going to land. So from a pilot point of view, it's very, very challenging.
Gordo, this is spectacular. It is absolutely spectacular looking at that command module America down there coming across the surface.
Sounds great.
Hey, Ron, listen, this ridge you're coming on over, just stick your hand out the hatch and grab a rock. We got the landing site. We're coming right over the front of it. Super targeting. God, we've got Family Mountain. We've got Corsa Massif. We can see the Scarp. We can see the Light Mantle. I've got the Great Cross, Camelot, Sherlock. Believe it or not, Houston, they're all there. Houston, I can even see Poppy right where we're going to set this baby down.
Very good.
Man, Gordo, this is absolutely spectacular.
Sure sounds like it.
During the next frontside pass comes the moment of truth. Challenger will descend to the surface of the moon and touch down at the Taurus Littrow landing site.
Okay, all flight controllers, go for powered descent. Retro, go. Fido, go. Guide, go. Control, go. Telcom, go. GNC, go. Ecom, go. Surgeon, go. Capcom, we're go for powered descent.
Challenger Houston, your go for PDI.
We are go up here for PDI. Master arm on. Okay, Houston, master arm is on. I've got 2 good lights.
Roger.
Oh man, are we down among us, babe? Woo. Ignition, Houston. Attitude looks good.
Roger, you're looking good here.
Okay, Gordo, we're out of 11,009. And the computer likes it. Stand by for pitch over. Oh, are we coming in? Oh, baby. I'll need the pro. I'll give it to you. There it is. Proceeded. And there it is, Houston. There's Camelot. Wide on target. I see it. We got them all. 42 degrees, 37 degrees, to 5,500.
Challenger, your go for landing.
Fuel is good. Here, get close. 500. 15 feet per second. 300 feet. Going down at 5. Going down at 5. Your fuel's good. 110 feet. Stand by for some dust. 80 feet. Getting a little dust. 40 feet. Going down at 3. Very little dust. Very little dust. Stand by for touchdown. Fuel's good. 20 feet. Stand by. 10 feet. Contact. Engine stop. Engine arm. Proceed. Command override off. Boat control ahead. Hold. Pings auto. Okay, Houston, the Challenger has landed.
Roger, Challenger, that's super.
Boy, you bet it is, Gordo. Boy, you said shut down. I shut down and we dropped, didn't we? Yes, sir. But we is here. Man, is we here. How's that look? Pressures look great. Manifolds right on. Brian, I had the meatball all the way. Beautiful. Jack, are we going to have some nice boulders in this area? Okay, the old camera's off. Okay.
Challenger Houston, I'm going to hand you over to the good Dr. Parker here. Have a good trip outside there.
Gordy, thank you. You do outstanding work, and we sure do appreciate it, babe.
My pleasure.
1 I think we're getting to our favorite part here. Click, click, click. Your helmet is locked. Your visor is locked. Oh, man. Woo! You ready for this? I hope so. Commander is on the porch. Oh, man. Oh, man. Oh, man. I'm on the footpad. And Houston, as I step off at the surface at Taurus Littrow, we'd like to dedicate the first steps of Apollo 17 to all those who made it possible. Oh my golly! Unbelievable! Unbelievable, but is it bright in the sun? How you doing, Jack? Fine. Jack, you're looking good.
Beautiful, guys, beautiful.
Hatch is closed. Hey, Jack, don't lock it. I'm not gonna lock it. We gotta go back there. You lose the key and we're in trouble. Well, I tell you, Gene, I think next generation ought to accept this as a challenge. To see them lead footsteps like these someday. A geologist's paradise, if I ever saw one. I never thought I'd do geology this way.
The Taurus Littrow site on the northeastern part of the moon at the edge of one of the large lunar basins called Serenitatis was selected as representing both a new part of the moon, which we had not explored yet, and having major features that would allow us to complete this first phase of lunar exploration. In the last chapters of a lunar history book that Apollo has the capability of writing. Those features are the edge of the Serenitatis Basin, where we have a very strong possibility of finding some of the oldest, if not the oldest, rocks that have so far been sampled and observed on the moon. And it also has the dark mantling deposit that is potentially some of the youngest volcanic rocks that we've seen on the moon. And then, of course, there's this other thing of the unexpected, and who knows what that's going to be. And that's really what makes it exciting.
Okay, here we go. Challenger's baby is on the roll. Okay, I'm gonna take a little spin around here. Don't run over me. Don't worry. Rover's getting tested for what it was built for now. Yep. I tell you, it handles just the way as advertised. Maybe even better.
17, we have a picture.
Oh, beautiful, babe. It's all yours. Okay. You're gonna have to get it down to my level. Tall guys are all alike. You're pretty agile there, Twinkle Toes. You bet your life I am. Okay.
The flag they're deploying is the flag that has been in the Mission Control Center here during past missions.
That's what looks like it's waving in the breeze. Yes, sir. How about right there? It does wave when you do that. Yeah, but did you ever see it vibrate like that? I've never put a flag up in the moon before. What?
We got a beautiful picture of you guys up down there.
Let me tell you, Bob, this flag is a beautiful picture. That's beautiful. This has got to be one of the most proud moments of my life, I guarantee you. First, I gotta find an Alcep site.
Schmidt carrying the Alcep about 100 meters east of the LEM. Gene Cernan will drive out to the Alcep site in the rover.
I say there, Jack, that looks like a big rock out there beyond. That's the one we were talking about earlier. We believe you now. Oh, you won't believe it. Oh, there goes a fender. Oh, shoot. Okay, was it the rear fender, Gino? Yeah, I caught it with my hammer and it just popped right off. Well, if it wasn't for that fender, I'd be ready to go. Makes me sort of mad. A little piece of the rail is cracked off, and I'm just going to put a couple pieces of good old-fashioned American gray tape on it. See whether we can't make sure it stays, because I don't want to lose it. Except the old-fashioned American gray tape doesn't stick to lunar dust-covered fenders.
Gene Cernan taping the fender on.
I never thought I'd be out here doing this. Bob, I am done. If that fender stays on, I'm going to take a picture of it, because I'd like some sort of mending award. It's not too neat, but, well, let's hope. Keep your fingers crossed, and I'll be more careful around the fenders. Okay, copy that.
Site selection in all the missions entails the utilization by NASA of a number of scientific advisory groups and the inputs of many individuals across the country, scientists primarily.
From the scientific point of view, in terms of the instruments that we're going to place on the surface, the landing site was picked because it gives us a tremendous network of scientific instrumentation that is still active from all the previous Apollo missions, spread across the face of the moon. We can see activity of earthquakes and meteor impacts, and it gives us a pretty good cross-section to pinpoint where this activity is and exactly what's happening.
How's the TV working? Beautiful. To coin a phrase, it's a panoramic scene of beauty. Oh, come on now, Bob. Say, Bob, what do you think of the terrain? Looks flat. Looks very flat and smooth. That's why you're an astronomer. Oh, well.
In the moon, we have a window into the very early history of a planet in the near-Earth part of the solar system. From 3.3 billion years ago back to, say, 4.6 billion years ago. That is a history which is almost totally obscured to us on Earth. On the moon, that's where lunar history starts, and that's why it's exciting to Earth scientists who have for years been trying to find out what happened to the Earth in that very early time, and an understanding of the processes that really affected the total distribution of materials on the Earth. And it's in those materials that lie our resources, and in the long-term understanding of the Earth so that we can exploit those resources and exploit them in obviously a now, I think, a much more enlightened way than maybe we did in the past, but nevertheless we must exploit them in order to preserve the civilization we're used to. That's reason number one, a little bit involved, but it is probably the primary material justification, scientific justification for going to the moon. Secondly, and equally important related to the Earth, is an understanding of the history of the sun. And within the soils of the moon, and within the rocks of the moon, the very surface layers of the moon, we are starting to see the effects of solar history on those materials. And there is no way we could get this information on the Earth or in orbit around the Earth, because what we see there is what's happening now. What we see on the moon, we can go through the record of the soil and see what has happened 100 million years ago and up to probably at least 1 billion years ago in some places on the moon. And if we don't understand the sun and how it affects materials and what the history of that sun has been as it has affected our own environment on Earth, it's going to be very difficult to understand how to preserve the environment that we now know, because the sun is still the prime mover, the prime force for change in the environment we have to deal with.
Well, Bob, I hope I can drill you a couple good holes. And I know you do too.
CERN drilling 2 8-foot holes for the heat flow experiment.
Hey, Bob, it's obvious that I'm going through some pretty tough stuff.
Yeah, Roger, we're seeing that, Gino. Looks interesting.
Yes, sir. Really working down there, huh? Oh, you betcha, man. I'm in something tough down there now. Woo! What bore are you in? Number 3. Oh, where do we find such men? If I let go of that drill and I wouldn't anchor to the ground, it'd throw me over the massif. It's funny how for every action there's an equal and opposite reaction, isn't it? Hey, I've heard that before. Oh, man. Yeah, that's what I've been doing. Oh, no. Come on, baby. Now that I got it. Okay. Stay there. Okay, back. Thank you.
Boy, Gino, that's what you call getting down into your work.
Bob, I'll save my comments till later. Oh, me oh my. We got them 3 cores, we got the neutron flux down, and we got 2 heat probes, and an L-step. Bob, I feel pretty good about that. That makes me feel pretty good.
Okay, congratulations.
Okay, Bob, we're about 15 meters from a 20-meter blocky rim crater. It's about 3 to 4 meters deep.
Okay, I copy that, Jack. Very good.
Oh, he's going slowly, Bill. Very slowly.
Try hitting, there you go. It's coming.
Outstanding.
The foreground features are somewhat different, simply because they were farther up onto the hill, I think. But otherwise, that's remarkable.
If you can hook your, that's what I'm going to do. I'm going to try and get it right. Hit it on the right side. It'll go this way, maybe. There you go. There's that man. He's right there. Try another one. Don't lose that one. Let me get that one for you. Right, I got it. Got it? Oops. Okay, bag 476 is the rock sample with a little bit of the soil near it. A chip. Chip off the rock. Be careful down in there. And it's the, watch it, Gene. Yeah, if I go down there, that thing's about 15 feet deep. Right. Here's the other chip. Got it. Okay. Oh, look at the dark minerals in there. Are those dark black? Yeah, they may be ilmenite or fresh pyroxene. Give me a pressure of pyroxene. Okay, you want my bag?
Jim, you better make it clear to Parker that we got to pull out.
Yeah, it's 29.5 minutes from now, but remember, they left this side a little bit late.
Okay, we copy that.
And 17, a reminder to factor into your thinking this is only a 30-minute stop, and it's about 20 minutes remaining.
Yes, sir. Well, we got to sample something. Okay. See if we can't fill this up for Christmas. You happy there? Yeah, that's good. Get your after. I'll get my after picture here. I'm going to take a close-up stereo of that contact. Definitely.
So what I really bring as a specialty is the ability, hopefully, of being able to integrate what I see, which in turn not only tells me what I should sample or what I should say or what I should photograph about what I see, but it will lead me to other observations. And this is something you gain by experience, no matter what field you're in. Field geology, aircraft flying, test piloting, botany, poetry, law, you name it. What you gain by experience is the rapid synthesis of what you're exposed to and a projection of that exposure into the next step. And so I don't feel myself very unusual being a scientist because we've had specialists before. And I'm really a geologist going to the moon, and we've got other types of scientists going on the Skylab program. Physicists, solar physicists, a medical doctor. We're just gradually evolving a phase of the exploration of space where we're now trying to apply specialties to the particular problems we have to deal with.
I was strolling on the moon one day in a merry, merry month of December. Oh, May. May's the month. May, that's right. May is the year of the month. When then, much to my surprise, a pair of ugly eyes. Almost looks like it's getting dark out, isn't it? Hope not. Or we is in trouble. I don't think we need an exercise period. Man, I hate this dust. I gotta make a new fender tonight. My tape didn't hold, it was too dusty. Oh man, look at that fender. That's terrible.
Okay, we'll take a look at it here while you're sleeping.
Get down a little bit more and you got another 2 or 3 inches. I can't get any lower, Willie. Me buttons are in the way. Okay, keep going. There you are. You're in. Godspeed the crew of Apollo 17. The hatch is closed and locked. Hallelujah. Cabin stable, Houston. How's it look to you?
Looks good to us, 17, and I'd like you to know you had a 7-hour and 12-minute EVA. I think is a tremendous job for what we might call a challenging EVA.
Bob, that's no pun. It really was. It really was.
I know it, man. I know it.
I tell you, I really wish you guys could have been here with us. You worked as hard at it as we did, if not harder. Harder, I think.
This is Apollo Control at 124 hours, 23 minutes. And aboard Challenger on the lunar service. Jack Schmidt and Gene Cernan are in the process of getting the lunar module reconfigured, ready for their sleep period, which the flight plan calls for them to begin at about 3.5 hours from now.
Good morning, Challenger.
Dum, dum, da-dum, dum, da-dum, dum, dum, da-dum. How's everything look, Gordy?
Couldn't look better. How's it look to you?
Okay, Houston, on this fine Tuesday evening, as I step out onto the plains of Taurus Littrow, Apollo 17 is ready to go to work. Oh, what a nice day. Funny, there's not a cloud in the sky, except in the earth. Whee! Okay.
Challenger, Houston, we've been working while you've been sleeping on a fix for the missing fender. John Young's been over working it out in a suit with the mock-up rover.
Sounds good, babe. Appreciate it.
Okay, I'll now turn the microphone over to Captain Young.
Hey, Dino, this is John.
Hello, John. How you doing?
Oh, just fine. You guys are doing a superb job. Really beautiful. Hey, we spent some time on this fender problem, and worked out a pretty simple-minded procedure, which involves essentially taking 4 of those lunar surface maps, taping them together with gray tape so that you end up with a piece of paper about 15 inches by 10.5 inches, and clamping the edges of it on top of the fender with the AOT lamp clamps. It's simple and straightforward, and the beauty of it is you're only spending about 2 minutes in the clamping operation, and it could save you up to about 12 dusting, I think, maybe. What do you think?
Hey, thank you, Dave. We're going to work on it right now.
Okay, hold it right there. Let me get the, okay. Think that'll stop the dust that way? Well, it'll stop some of it if it stays on.
Crew is using maps to make that fender. The clamps are from the optical alignment telescope lamp. As you can see, it's only a paper fender, but the moon is real.
I'll hold it right there while I clamp it down. Man, that's tight. I think that'll stay. I think it'll stay.
Okay, it's
The maps are configured.
sounds like a good attempt, men. We'll hope it works.
Does that look good to John from what he did?
It looks exactly what he did, he says.
We gotta take a picture of that fender if it works. Hey, man.
Gene, you're good as is. We're ready for you guys to go.
Okay, we are moving right now.
Okay, we're marking that.
The crew has started for Station 2, the most distant of the stations, more than 7 kilometers away.
It's a little rocky out here. Yeah, it sure is. Okay, the fender fix is working so far. And I'm averaging probably 10 to 11 clicks. It's not exactly straight line navigation, but I think I can hold most of it.
Roger, beautiful.
The Taurus Littrow site for Apollo 17 is one where at the mountain front you'll be hearing the names South Massif and North Massif as we explore that part of the moon. At these fronts or massifs, there is an excellent probability, because of the impact event that formed the Serenitatis Basin, we will see rocks that form the early lunar crust. The big emphasis there will be to see these very old rocks that will help push this history book of the moon back right up to the very earliest possible time that we can examine on the moon that we know about, potentially as old as 4.4 or 5 billion years old.
Hold it, Jack. Oh, watch it. Hold it, hold it. You can go around that one. you betcha. Woo! Gonna wrinkle your toes now. Oh, I wouldn't worry, Gene. Okay, the surface is not changing in terms of the detail, the surface texture of the fine-grained regolith. Most of the brightest craters have a little central pit in the bottom, which is glass-lined. Look at that crater. Woo! Oh, man, a Shivets. Woo! Boy, I tell you, are those massifs getting to look big now? Holy moly. Man, this has been a trip. Man, I tell you, we're really up on top of this thing.
You guys been driving 64 minutes.
Well, we're almost ready to park.
Okay, beautiful.
We're right where we wanted to be for Station 2, and it looks like a great place.
They parked. Station 2 is right at the base of the South Massif.
Bob, I want to get this camera fixed.
Okay.
Any other service I can be? Can I change your oil?
Thank you, Dino. It looks much better.
Man, that's the way to come downhill. Just don't stub your toe. Man, there's some boulder rolling rocks here, Jack. Hey, Gene. Yeah. Set up right there. Let's get that big class. Oh, the class? Yeah. Yes, sir. Good eye. Good eye. Big white class. Good eye. Gray matrix picture. Good eye. Man, that's a prize. Bob, you still there?
Roger, still there, listening with great delight.
Got a bag? Got a bag. The soil from right underneath the rock The old boulder rolling trick. Don't hit the rover. 17, if you want to just take a minute, you might look up in the sky and notice beautiful Mother Earth. Hey, there she is. Oh, boy. There is orange soil. It's all over. Hey, it is. I can see it from here. It's orange. 3, 2, 1, ignition. Right away, Houston. Take your final look at the Valley of Taurus Metro. Here, man, completed its first exploration of the moon. May the spirit of peace in which we came be reflected in the lives of all mankind.
Ignition sequence has started.
Liftoff. We have liftoff.
Fido, go. Guide, go. Control, go. Telcom, go. GNC, go. Ecom, go.
The Eagle has landed. We copy you down, Eagle.
It's one small step for man, one giant leap for mankind.
In the beginning, God created the heaven and the earth. And God said, let there be light. And there was light.
Okay, Houston, we've had a problem here.
Say again, please.
Oh, Houston, we've had a problem. And it's been a long way, but we're here.
Of course, when I was selected for the program, I had very high aspirations of flying a lunar landing, but Apollo at that time, when Germany was going on, although it was in existence and in work, for those of us who were very deeply involved in Germany, it was still quite a step away. I used to give a talk now and then to different groups throughout the country and talked about someday we're going to walk on the surface of the moon. Not just go there, but walk on the surface of the moon. And I believed it, even though I found it hard to believe myself. I did believe it because I believed in what I was doing. But I turned around one day and I found out, gee, I was one of those guys who was walking in space. And with a little luck and God willing, I'll be one of those guys who's going to walk on the surface of the moon. And even having done some of this, it's still almost unrealistic to me.
Okay, are you guys ready? Here we go. It might sound corny, but the view is really out of this world.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning it safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space. None will be so difficult or expensive to accomplish.
in spite of the fact that I've had a chance to fly a couple times, I've been close to the moon. I haven't made that moon landing, and believe me, it's no easier today than they were in the past, and certainly they're not for a crew who's never made that lunar landing before.
I think just like everybody else has flown, I and all the people who fly with me and after me will bring very special experience to the program. Experience gathered generally prior to becoming an astronaut and then added to while they have been an astronaut. My experience just happens to be in the field of geology, and in particular in the observation of materials of the Earth as they exist in the field. That's what basically a field geologist does. In the case of exploring the far frontiers of space, a geologist has an advantage because that's his livelihood and that's what he's been doing most of his life. I don't feel that unusual. A lot of people think of it as being unusual, but it's really just another specialty. Hopefully, we open up with this the possibilities of applying other specialists to other problems.
Apollo 17 is what we call a J mission series, or it's a follow-on to Apollo 15 and 16, where we really sort of change the capability of the spacecraft. We have more payload on this flight. As a result, we have quite an extensive and heavier scientific package in our spacecraft, which of course means it takes longer time to deploy it, to set it up, to get it working. With that in mind, and to spend additional time on exploring the geological finds we hope will be in Taurus Littrow, our landing site, we hope to spend a little bit longer time on the lunar surface. We added a lunar rover to the lunar module so that we could go further distances from the lunar module after we landed, get in areas in terms of geological exploration and exploration of the moon that we couldn't get to before.
We've been training for about 12 months, maybe slightly longer than that. It's hard to remember once you get involved in this thing how long you've been working on it. But of course,